You and I will build this three-dimensional framework consisting of capabilities, limitations, and skills to understand and better differentiate between ChatGPT and GPT-4. This will help us in expectation settings when it comes to the capabilities of these models and help us in designing more informed use cases. To help us design this framework, I have condensed the 99-page GPT technical report into an interactive dashboard. Link to the dashboard and all my analysis is available in the description box below. One may ask, I can use GPT-4 for everything. Why should I care about the differences between ChatGPT and GPT-4?
Good question.
I believe there are three reasons why we should care. The first is the most important. Understanding the differences between these models helps us build an intuition and develop insights into these models. Understanding strengths and weaknesses of these models will help in setting realistic expectations of performance and use cases that can be built. The second is inverse scaling. This is important because it's counterintuitive. What inverse scaling talks about is that as the model complexity increases, the performance of that model decreases on certain tasks. So you could have a model that's been trained on tons and tons of data and has billions and billions of parameters, but it would perform worse on these tasks as opposed to some of the simpler or relatively simpler models.
No, it's not true. That's impossible.
One such example is shown in the GPT-4 technical report, where ChatGPT's performance is lower than that of OpenAI's ADA, which is a much simpler model. This inverse scaling issue is very important for us to understand when we are building our use cases. It should not happen that we end up paying much more for a complex model and actually get lower performance. The third reason is money. More complex models cost more. Depending upon the version of GPT-4 you're using, we can end up paying 1.5 times to 6 times more than had we used ChatGPT for the same task. Let's start building our framework. The first one is limitations. This is the one that does not get a lot of press, but it's very important for us to understand and monitor. There are 4 limitations that stand out to me. Let's build 3 of them now. The first is hallucination. The models can mix up context and produce outputs that are not relevant, incorrect, misleading, or worse, damaging and harmful. This is a problem with all large language models. Let me share an innocuous example. When I was researching for my next video topic of how to use ChatGPT and GPT-4 for effective job search, where I was effectively trying to match an effective resume to a job description. And what I found was that these models were mixing up the context and updating my resume with work experience that I did not have just to match the job description. Now, this is a simple example that sheds light onto a major issue that these models have of mixing up context and hallucinating. This would create a lot of problems when you're trying to automate our use cases. It's important for us to build guardrails and checks along the way to ensure that the outputs that these models are generating are not mixing up context or hallucinating. The second limitation is that of context window. Think of this as the amount of information that the model can look at or process at the same time. So as long as our data is within the context window limitation, we will get really good results. The moment the data that it would need to process at the same time goes beyond the limitation of that context window, the results that we're going to get are going to be of lower quality. So what it really tells us is that if we're trying to get better results from these models, we want to think about ways and means by which we're able to reduce the amount of information that the models would need to look at a given point in time to come up with a correct answer for whatever the use case that we're trying to build. Now, GPT-4 has a context window that's 4 times that of ChatGPT, and therefore one can imagine that the performance that GPT-4 is able to give is much better than ChatGPT. But at the same time, if we are able to find ways and means by which we can reduce the amount of information that's needed to be processed at the same time, we'll be able to build much better performances with any of these models. The third limitation is bias. Let's try to understand how bias gets into these models in the first place. But for that, let's try to understand what were these models designed for. On a very high level, the GPTs, or generative pre-trained models, are designed to generate the next word given a sequence of words. So if you're given it a phrase, my name is, the job of the GPT model is to generate the word that's going to come after the phrase, my name is. How it does that is based on pre-training on a lot of data. It'll look at all the data and train to come up with the best combinations or probabilities given the sequence of words. Let's just build a toy example and say this, it gives 3 names. The first is Gurinder, and that word comes, say, 1,000 times in the data corpus. The second is, say, Sam, and that word comes, say, 20,000 times. And the third word that comes up in this sequence is Wilson, and say Wilson comes 1,000,000 times. So now, based on these combinations, the model would have already calculated the probability or the best suited probability for the given sequence. So whenever the word phrase my name is given, the output that the model would give. Wilson! The models have been trained on a vast corpuses of data which have been sourced from the web, and all the inherent biases that would exist in that data has also been transferred over to the model. OpenAI in the documentation clearly talks about the efforts that they've made towards that end to curb these biases. But my impression on this is that the focus area is more case-to-case basis. They've tried to build automations around clearing those biases, and clearly it works better in the case of GPT-4 as opposed to ChatGPT. But I'm pretty sure that there are so many cases which would fly under the radar. And therefore, when we are building our use cases using ChatGPT or GPT-4, we should be very cognizant of the fact that the outputs can clearly have biases to them. So in our framework, after limitations, the next dimension that we want to build upon is capabilities. Now think of capabilities as what OpenAI has envisioned the models to do. They've put in thought, time and effort to make this happen. I've identified 12 capabilities, and let's talk about 3 of them now. The first is step-by-step explanation. Now this has made its way into product design for Bing, GitHub Copilot, and other Microsoft products. As the name suggests, it allows the users to tell the model and to explain the output in great detail. I think so this capability serves 2 purposes. The first, it just could be based upon the use case where we want to explain to the end user how the output was received. And second, it can help us to build guardrails to understand that the model is using the processes that we want it to follow. The next capability is text summarization. Now, as the name suggests, it would essentially take a large amount of data and would highlight the key elements of that. But what's really good about this capability is that it also tends to work with larger amounts of data. A big one for me is improved performance based on training on specific data sets. We'd see a lot more of this once we get into the skill sets and try to identify how GPT-4 has become much better at certain tasks than ChatGPT. And I believe it is based on this specific capability. The other capabilities that we are adding on are recommendations, writing assistance, fact checking, translation, answer questions, define a term, review. And if you encounter any new capability, you can update the framework, and I would request you to share it in the comments so all of us can benefit from the same. A large section of the GPT-4 technical report has been dedicated to a comparison of ChatGPT versus GPT-4 on exams that we humans give on a wide range of subjects ranging from biology, maths, coding, all the way to wine theory. I found this thing really interesting, but the information was contained in a lot of tables and a lot of graphs, and it made it very difficult to understand and compare them well. So I took the 34 exams and identified the skill sets that they were testing for. And from the 34 exams, I reduced them down to 9 skill buckets. Let's just take a quick look at the dashboard. So the dashboard primarily has 3 sections. The first one talks about exams, and you can select any exam of your liking. It's got all 34 that were mentioned in the GPT-4 technical report. The next section is buckets. So buckets are the 9 buckets that we've condensed those 34 exams into. And then the main section consists of the graph. So where we can see the bucket followed by the exams that are there, followed by the chart. Now, if you look at the bar that is there, the higher the better, or the longer the better. So for example, this bar represents the percentile. What does 75 percentile mean? It means that you're better than 75% of the test takers. So let's say, for example, we're looking at wines, and there's an exam called as Advanced Sommelier Theory exam. So what does this really entail? So what you can do is you can just hover over any of these bars, and it's going to give you information regarding what this exam is about, and it'll also give you an example question. Let's build a first skill set, coding. And there are 4 exams. Lead code, which has 3 of them going from easy, medium to hard, and code force rating, which is considered a more difficult form of competitive programming. Now, if you look at lead code easy, we've seen a huge jump in GPT-4's performance. Now going from 29% to 75%, which is a huge jump. And I think so this has a lot to do with the context window. Right? So as it is able to see more information, it's able to process more, it tends to do much better there. The other thing is that once you move beyond this and you get into the territory of medium to hard to even extra hard, if you can just use code force for that, you see that the performance does not jump that much. So if you look at lead code medium, the performance just moves from 10 to 26%. For hard, it's just a 6% improvement from 0 to 6%. And for code force, it does not even improve an inch. What this tells us is that if you're looking for use cases that involves easy computer programming, then that's the time when we can consider GPT-4 for. But we should generally stay away if it involves more involved computer programming. But having said this, there are tons of use cases that we can build around code structures as such, which would involve other capabilities such as summarizing. So you can have code summaries that could be built, but that would not effectively be using the code building facility, but it'll be using a capability which would be more of text summarization. Let's build a next skill set, which is maths. The 5 exams that the skill set was tested on: AMC 10, which is a maths test for students in 10th standard; AMC 12, which is a maths test for students in 12th grade; AP Calculus, which is a high school exam for calculus; SAT Maths or SAT Maths, which is effectively an exam for entering into undergrad; GRE is an exam to enter into a master's program. So they've been ranked in order of perceived difficulty. If we look at this, the performance of GPT-4 is phenomenally higher than that of ChatGPT. In AMC 12, it does at 66% as opposed to 8% by ChatGPT. In AP Calculus, it does a 59% as opposed to 7% by ChatGPT. And also for SAT Maths, it's from 89%. And the same we can see for GRE quantitative also, where it does 80% as opposed to 25% by ChatGPT. So the ruling is pretty clear that GPT-4 is much better than ChatGPT when it comes to maths. But there are 2 key findings here. The first is counterintuitive and therefore I believe is very important for us. If we compare AMC 12 performance with that of AMC 10 performance, AMC 12 GPT-4 is at 66% versus 8%. So that's a phenomenal jump, some 53% higher. But if you look at AMC 10, the performance is exactly the same at 19%, no improvement. And the important part here is that AMC 10 can be perceived as an easier exam than AMC 12, because at the end of the day, AMC 10th is given by students in 10th grade, AMC 12 is given by students in 12th grade. So 10th versus 12th, I would expect AMC 10 to be much easier. So this is extremely important for us to understand that at the end of the day, the learning of these models is very different from the learnings that we humans have. If we are good at something difficult, we would assume that we could do something easier. That is not the case for these models. So when they learn something difficult, they don't go through the same learning process that we go through. And therefore, to automatically assume that if they're good at something really difficult, they will be really great at something which is very easy. So that's a very important point because it's counterintuitive. And when you're building a use case, we want to confirm that the performance is good on that specific task and not assume that it's going to be good at that. The second thing that I believe is important here is the performance on SAT maths. If you look at SAT maths, ChatGPT doesn't do a bad job. It's at 70%. GPT-4 does a better job at 89%. And I believe the reason for this is algebra. ChatGPT does well in algebra. And why algebra is important? Because in most of our use cases, we just want the models to be able to add, subtract, and divide. There's so many use cases where you can just think about the models as being able to add and subtract. We really don't want them to be able to do calculus for many use cases. And why that's important? Because remember that GPT-4 can be as expensive as 6 times than ChatGPT. So if you can get a good performance with ChatGPT, why do you want to pay 6 times more for GPT-4? The next skill set is that of Vine. The way I want to look at it is the ability of these models to make recommendations. The exams, introductory, certified, and advanced familiars, are primarily tests of recommendation abilities. So if you're given a certain characteristics of wine A, can you find wine B that matches with that? The takeaway over here would be that for our use cases, even ChatGPT as a recommendation engine is not that far off. The next skill set is science. Both ChatGPT and GPT-4 provide amazing results in science skill bucket, but I believe the real story is in the details. Let's just quickly look at the exams that are conducted. So we have AP, which stands for Advanced Placement Exams. So we've got close to about 4 of them: biology, chemistry, environmental science, and physics. And then we have 2 of these, which are USA BO, which stands for the USA's Biology Olympics. Biology Olympiad, and USNCO, which again stands for the USA Chemistry Olympiad. Now, if you look at these exams, the Olympiads are more difficult than the AP exams. So first, let's just quickly look at the AP Environmental Science, and where we see both ChatGPT and GPT-4 do phenomenally well at 100%. Now comes the meat of the story, the comparison between biology and chemistry. Let's look at chemistry first. If you look at AP chemistry, which tends to be an easier exam as opposed to the chemistry Olympiad, the AP chemistry performance of GPT-4 is much better than ChatGPT. From 46%, the performance has jumped all the way up to 48%. So roughly 42 percentage points up. But if you look at the chemistry Olympiad, we don't get the same lift in performance. We get a better performance. We're moving from 40% to 60 percentile, but we're still not getting that 40 percentage point jumps as we saw in the AP tests. But now let's compare this with biology. If you look at AP biology, the performance for ChatGPT was phenomenally good, 85%, but GPT-4 goes all the way to 100%. It's not at 90, it's not 99, it's 100. And then it repeats the same thing again with the Biology Olympiad, which is a much more difficult exam. So we're going from 33% for ChatGPT to all the way again to 100%. Why is there such a huge difference in performance where biology is doing 100% throughout, and whereas it's not able to do the same for chemistry? I believe that this is the case of specific training.
I said to them, hey, if you can pass an advanced placement biology exam where you take a question that's not part of the training set, or a bunch of them, and give fully reasoned answers, knowing that biology textbook is one of many things that's in that training corpus, then you will really get my attention.
The next skill set is statistics, and I believe this is a game changer. GPT-4 does much better than ChatGPT in terms of performance, but I believe it's the functionality that GPT-4 has with GPT-4 Vision that takes it a step higher. GPT-4 is able to convert images into text, and therefore you'll be able to give it a graph and it'll be able to perform statistics on it. There'll be multiple use cases that will be built around this specific feature. The next skill set is law. I find it absolutely fascinating to see GPT-4's performance on this. There are two exams that have been put under this bucket. The first is LSAT, which is an exam that one would need to give to enter into a law college. And the other is Uniform Bar Exam, would be an exam that somebody would need to clear to practice law in the United States. If you look at LSAT, the performance of ChatGPT is at a reasonable 40% compared to GPT-4, which blows it out of the water at 88%. But I believe ChatGPT's performance of 40% has little to do with law, but more to do with the reading comprehension questions that probably would be there. If you look at the Uniform Bar Exam, the performance of ChatGPT is just at 10%, and GPT-4 is as high as 90%. Now that really opens up a lot of use cases if you're trying to build around legal cases. With this, we've completed the framework consisting of capabilities, limitations, and skills. I hope you found this helpful. If there's any other skill, limitation, or capability that you would like to add on, please do update in the comments below. Thank you so much for watching, and wherever you are, I wish you well.